Welcome to the lecture series on soft computing in computer science. In this lecture, we are going to deal with the continuous series lecture on intelligent optimization algorithms. Of course, this lecture is a fundamental lecture and that discuss about the optimization methods, how to handle constraint in optimization methods and how to solve economic dispatch and unit commitment problems. More detailed about economic dispatch and unit commitment problem may be discussed in the subsequent presentation. Here to start with, we need to know what is an optimization. So optimization is the process of finding the best solution from all possible solutions. It is widely used in various fields such as engineering, economics and machine learning. Types of optimization problems. The word optimization can be treated in two forms, one is minimization, another one is maximization. Accordingly, we have minimization problem that tries to find minimum value of an objective function and maximization problems that tries to find maximum value of an objective function. The main key concepts in optimization method is two things, one is objective function, another one is constraint. What is an objective function? The objective function is the function that is to be optimized. What is a constraint? Constraint are nothing but the condition that the solution must satisfy. These two things are play a vital role in proceeding with any optimization problems. So when you treat any problem as an optimization problem, first thing you should think about how to write optimization objective function for that optimization problem. Second, is there any constraint associated with the optimization problem? So if these two things are ready, then automatically the optimization task is enabled and you can solve the problem in an optimal way. So what is the importance of optimization? So in general, optimization helps in making efficient and effective decisions. So looking into the applications, when we deal with applications of optimization, we can have lot of things. One is engineering optimization and based on economics and what are the things that cover machine learning and finally operation research. Let me come to a point. Let me take the topic as design of structures, control systems and electrical circuits among the engineering sector, and resource allocation, cost minimization and profit maximization comes under economics. Training the models and hyperparameter tuning comes under machine learning. Logistics, supply chain management and scheduling comes under operation research. So these are all the major applications that we can find the role of optimization. So engineering, economics, machine learning, operation research. So what is this optimization? This optimization is the task of making effective and efficient decisions in almost engineering, economics, machine learning and operation research related problems. What are the two categories of optimization methods? There are two approaches for optimization, one is minimization approach, another one is maximization approach. That means two categories of problems in optimization, minimization problem and maximization problem. But here we have two different methods for optimization, one is gradient based optimization, another one is non-gradient based optimization. Coming to gradient based optimization, in gradient based optimization a gradient is utilized. What is gradient? A gradient is derivative of an objective function is utilized to guide the search or to look for the search pattern. So that is the gradient based method. What is non-gradient based method? In non-gradient based method and it essentially do not require any gradient of the objective function and it is useful when the gradient is difficult to compute. When the gradient is very difficult to compute, then you can go for non-gradient based methods. Under gradient based method you have gradient descent and Newton's method. Under non-gradient methods you have genetic algorithm and simulated annealing. So whenever you want to solve an optimization problem, you have to decide upon whether you go for gradient based method or you go for non-gradient based method. If you go for gradient based method, then you should think about how to utilize the derivative of the objective function. Otherwise, we need to think about the gradient of the objective function. But on the other hand, when you think about the gradient is very difficult to compute, then automatically you have to go for using the non-gradient based methods. The examples for gradient based methods are gradient descent method and Newton's method, whereas for non-gradient based method it is a simulated annealing and genetic algorithms. Let me come to know what is gradient search. So, gradient search methods are class of optimization algorithms that use gradient of objective function to guide the search for the optimal solution. See point, gradient of objective function. So, every time you need to check about the value of the gradient. According to the value of the gradient, the search process is going on. What is the search process? The search process is nothing but the search for looking to the optimal solutions. So, whenever you want to deal with gradient based optimization methods, they are the set of optimization algorithms that uses gradient to look for the optimal solutions. What are those? They are machine learning methods and neural network methods. So, those methods are always gradient based or derivative based methods, and those are collectively called as gradient search. Non-gradient search. Before that, you should know how that iterative optimization for finding the problem can be refined. So, an iterative optimization algorithm for finding the minimum of a function can be written as, see, the next step of x is equal to old step of x, some learning rate into change in gradient. So, where here we may take that the alpha is a learning rate, del f xk is the gradient. So, when you want to solve an iterative optimization algorithm for finding the minimum of a function like this, then you can have the idea of using what is alpha. Alpha is the learning rate, and what is f of x? F of x is the gradient function at xk. Gradient descent variance. So, there are other methods that similarly utilize the idea of gradient descents. One of the best method is stochastic gradient descent, SGD, stochastic gradient descent. Here you also have this one, here f of I, fi of xk. So, gradient for single data point or a mini batch. So, that thing you should remember, this is the stochastic gradient descent. When you go to the previous one, this is del f, no fi, del f I, but here del f I is included. This is one of the variant. So, there is a smaller change. When you bring smaller change, if it has a greater impact, then you may treat that method is also as a one of the method of the gradient descent method. So, here if you look at it, the new value of xi is equal to old value of xi, and it is nothing but the product of learning rate with a gradient. The gradient may be a single point or it may be a batch of points. What are the pros and cons of gradient search? Well, let me discuss about the pros. When you want to use gradient search, suppose if you are using a data set and that data set is very huge in size, then definitely you can go for gradient search. And if your problem is of convex in nature, then you can go for gradient search. So, these two points are the ones you can decide the gradient search. On the other hand, if you apply this gradient search, then you can find that this gradient search is very sensitive to noise. Particularly it is very sensitive to learning rate. So, if you keep on increasing the learning rate, that learning will become very poor. If you keep on increasing the learning rate slower, the learning will get stuck. So, you should achieve a desirable balance between the maximum and a minimum learning rate. So, you should achieve a general balance between generalization versus memorization, that we have already discussed. So, another important point is it gets stuck in local minima, where suppose if the problem is a non-convex. See, if the problem solution is like this, there are so many minimas, right, there are so many minimas. So, your ideal solution will get stuck. Say for example, here in this point if it find this as a global minima, but there are some other minimas are also, right. So it get out to jump out from that and look for the another way, but it can struck, it will be within this limit, it can't able to come out for certain non-convex problems. So when you want to decide which one I have to go for, whether I have to go for gradient search or I have to go for non-gradient search, in that case I need to think about if the data set is a large data set, so definitely I should go for a gradient search, and if my problem is well suited for a non-convex thing, then I did not go for gradient search, because gradient search is well suited for convex type of problems. And you should always think about learning rate, whether it is sensitive or non-sensitive, you should think about it, and accordingly you should decide. What are the practical applications of gradient search? Training the neural network to optimize the weight. So it is a kind of recommendation system. When you want to find the optimal values for the weight during the training of the neural network, then you can go for gradient search. Maybe the very popular algorithms like backpropagation and other related algorithms mainly use gradient descent approach. Another important problem is logistic regression, particularly when you want to solve a classification problem that is of binary in nature. So for a binary classification problems, you can go for logistic regression. Whatever may be the issue, when you want to optimize the cost function, say for example my cost function is something else and I want to optimize it, because why you want to optimize? Because I want to find the best parameters. In order to find the best parameters, I need to optimize the cost function, and in that case I can go for logistic regression, and this is one of the applications of gradient search. What this gradient does is helpful in doing a kind of recommendation, that is what is the recommendation here? Ideal value or finding the optimal value for the weights in while training the neural network. This gradient descent helps in optimizing collaborative filtering algorithms, that is most important. Whenever you want to use a collaborative filtering algorithm for a particular kind of applications, when you want to decide for sentimental analysis or opinion mining or something related to the things which you wants to give recommendations, then this gradient descent method is very useful and is very helpful, because it always tries to optimize the algorithms that is very suitable for collaborative filtering. And the last one is computer vision. In computer vision, this gradient search algorithm is used to optimize the CNN model. What is CNN model? Convolutional neural network model, particularly for doing the task of image classification and object detection. So for this you are going to use computer vision. So these are all the some practical applications of gradient search. Let me come to what is non-gradient search. Non-gradient search, by the name implies, it is non-gradient, so without the use of gradient. So non-gradient search methods are methods that do not use the gradient of the objective function. So what are the two things needed for solving an optimization problem? One is objective function, another one is constraint function. So if the objective function is not going to use the gradient, then automatically the function comes under non-gradient search. And what are the problems it is suitable? It is suitable for problems where gradient is difficult to come. If you find or if you feel based on the number of solution variables or number of decision variables, computing the gradient is very difficult, don't burden the system, don't overload the system, don't always force the system to do some complicated calculations by calculating the gradient. So because it is very difficult, right? Rather than that, you can go for some sort of search algorithm that is called non-gradient search algorithms. The very popular algorithms that comes under non-gradient algorithm is the one that we have discussed already, that is genetic algorithms, and other related algorithms like you have swarm intelligence algorithms, that what we have discussed, particle swarm, ant colony, artificial bee colony, and so on. So all comes under, and very particularly the most important algorithm is simulated annealing. So it is called as SA. So all these are belongs to non-gradient search based optimization algorithms. Pros and cons of non-gradient. When you want to handle, when you want to handle very huge data sets, gradient search. But suppose when you want to handle the function, that is the objective function is complex and multimodal. See, when my objective function is very complex and it is multimodal, then definitely you should go for a non-gradient based approach. and the most important is the previous iteration gradient value, that is a change in x value, that is not required here, and we need not remember that previous gradient value. So, in general it is also taken as one of the pros of non-gradient search algorithm, that means it does not require gradient information. And when you compare with gradient search, it is slower because it has to search all the possibilities, and we may treat that as a population based research, right. So, since it is treated as a population based research, so it is has to think about large number of values or possible values and then come to a definite conclusion. So, in doing so generally it becomes very slower. So, it means that when you want to have a problem that has to be solved in a very least amount of time, then you can go for gradient search. So, if the time is not a problem at all and you want to focus only on the solution, see time, solution, you should compromise two things that. So, then you need to go for gradient based methods. So, for and the next thing, since this method is totally a non-gradient based search method, if you use this method, then you may find lot of tunable parameters, number of populations, population size, decision variables, a range for the decision variables, like that. Let me show you in the subsequent slides with respect to genetic algorithm, what are the control parameters that are needed for proceeding with the genetic algorithm. So, when you go for choosing any non-gradient search based method, you should always very careful about the number of parameters. Among those number of parameters, what are the tunable parameters? You should very careful in choosing those parameters and tuning the values of those parameters. See, what are the GA's kind of control parameters? You first thing is objective function, that is very obvious, that is the given one to optimize. From the objective function, what are the things we need to check with? Number of solution variable, range for each solution variable, what is the representation scheme. In case if you are using the binary coded GA, then what is the length of the binary string, population size, number of iteration, and there are genetic operation, right, the genetic operation, right, selection, crossover, mutation. For selection you need to mention selection probability as well as a tournament size, if it is case if it is a tournament selection. So, crossover probability and mutation. See, there are 10 control parameters in general to proceed with a genetic algorithm, all are related with the objective function. So, to solve any optimization algorithm using non-gradient based search method, the first requirement is objective function, the second requirement is constraint. So, from the objective function you need to derive these many parameters, and these many parameters changes from algorithm to algorithm. Suppose if I am using particle swarm optimization, I need to optimize only few parameters. Suppose if it is ant colony optimization, so my parameters are very limited. So, like that. So, for genetic algorithm you should look for these many parameters. Now, let us take genetic algorithm as a one example for gradient search, non-gradient search, and other techniques are I treated as a traditional text. So, I want to compare the operational principle behind a non-gradient search as well as a gradient search. So, let me take that comparison as a GA versus traditional technique. First of all, GAs are coded form of functional values, that you should remember. In case if you use a binary coded GA, definitely this point will be a very hold good one. In case if you use a gradient based search, then you can use directly the value that is responsible for optimizing the given objective function. But whereas in the case of genetic algorithm, you do not go for direct representation, either you go for some coded form of representation. So, that is the major important thing, and this process is called encoding. This process is called encoding, right. Another important point is it uses a set of population of points to conduct a search. So, genetic algorithm starts with random initialization of set of possible values. What is this random initialization of set of possible values? These are all the values related to, let us take this function f of x equal to x3 plus x2 plus 5. So, there are two variables x3 and x2, I need to decide the number of possible values for the x3 and x2. So it means that I have a population of values, not a single value, I have a population of values, and all these populations are involved in conducting the search. So always GA uses a set of population to conduct a search. So that thing you should remember. So in general, GA looks at many different areas of population space at once and uses all this information. That's why the search process is very effective. If you want the search process is very efficient, then gradient based, non-gradient based search like genetic algorithm. If you want effective with respect to time, then you can go for. Another important thing is payoff information. So this is most important thing, payoff information. So something is needed to guide the search, right? Say for example, many search techniques like the gradient search technique need some variety of information to guide themselves. Let us take an example, hill climbing methods. It requires derivatives. Based on the derivative only it changes the direction. But what GA is need? GA is needed about the fitness. What is this fitness? It is nothing but the value obtained after calculating the objective function. So the objective function is also called as a fitness function. So this fitness function and or the value that is calculated based on the objective function, that the fitness value is going to discuss about the goodness about a point, whether that point is good or not, whether the value that you have taken is really using the payoff information or not. Accordingly you should vary the values. So then it means that the payoff information is nothing but the guiding information that guides the search process, right. Another thing is the GA is probabilistic in nature and it is not deterministic. When you take the gradient search, it is deterministic in nature. You should determine the value. After determining the value only and based on the determinant value, then you should guide the search process and you will go for calculating the derivative, derivative by derivative, and at one point after you should stop that process. But here it is non-deterministic in nature, most probably it is probabilistic in nature. Why? Because of using the randomization, because every value for the control parameters as well as for the solution variables, all the things that you need to generalize in a random manner. So that is the idea. And most importantly, the very powerful factor with respect to genetic algorithm is it is parallel in nature. It means that genetic algorithm or the associated algorithms that are in general gradient based, non-gradient based research algorithms are easily parallel with some other algorithms. So it means that you can create any hybrid algorithms. Any hybrid algorithms is helpful, can be created using the genetic algorithm. So in order to solve any problem, if you find search, then GA followed by a classification task in neural network. So genetic algorithm trained neural network, or you may say that evolutionary fuzzy system, evolutionary fuzzy system, EFS, evolutionary fuzzy system, or genetic algorithm trained neural network. So we may say like that. So this is all about the way in which the gradient and non-gradient based methods are differing. So when you will use gradient based method when the data set is very huge in size. When you use non-gradient based method, when the function that is you are going to optimize is very complex in nature or very multimodal in nature, then you go for next. So that's all about objective function. So based on the objective function, you can either go for gradient and non-gradient method. So the objective function, if it is connected with any data sets and if the data sets is huge, then you go for gradient search. If the data set is not a matter and if the objective function is very complex and multimodal, then you go for non-gradient search. And the most important other factor in optimization method apart from objective function is the second one is constraint. How to handle the constraint? So the constraint are nothing but it is the restriction that is imposed on the acceptable solution. Suppose say for example you are solving an objective function f of x and you are obtaining a solution and you are very much interested in that solution and you feel that the solution is very good solution for your objective function. Suppose if that objective function satisfied by a decision variable x1 or x2 or whatever it is, if it is failed to satisfy the constraint or the constraint may restrict that value of the solution variable, then you need to focus on how to handle that constraint. So that's the thing you need. So in general, what is constraint? A constraint is a restriction imposed on the objective function. There are a lot of constraints: equality constraint, inequality constraint, hard constraint, soft constraints. So while solving any optimization problem, you are always ready to face the constraint. You are not asked to solve any optimization problem without constraint. Constraint is always expected, even if it is a range constraint. Range, say for example x1 plus x2 f of x, x1 belongs to 0 to 5, x2 belongs to 0 to 3. So this is range constraint, or otherwise called by the name inequality constraint. Even if that constraint is of this kind of nature, then also you should think about how to handle it properly, or how to avoid violation during the evolutionary process, because it is an iterative process, right. So for every iteration of the non-gradient based search algorithms, you need to always check with the constraint whether we have violated the constraint or not, or whether the solution variable that we have obtained are within the constraint or not, that we have to check. So each constraint, whether if it is equality constraint or inequality constraint or hard constraint or soft constraint, it needs a special attention. Why these constraints are very important for genetic algorithm? Because the constraints only shape the search and feasibility. What is my boundary and whether the solution is feasible solution or not. My solution may be an optimal, but whether it is feasible or not, then it will be checked using the constraint. And otherwise you may check that this constraint influence the fitness landscape and selection. Also it is very responsible for causing infeasible offspring creation. When you want to do the constraint analysis, when it is going to affect the convergence speed and solution quality. So you have to require a special handling techniques for handling the constraint. See, what are the three reasons? One is it influences the fitness landscape and selection. Second, it causes infeasible offspring and creation, and the third, it affects the convergence speed and solution quality. So when you want to do optimization, you may obtain optimal value, but whether that optimal value is feasible or not, that you should look into it. So these are the three factors that constraints are matter for genetic algorithm, and you need to have a special handling techniques for handling the constraint. So there are many methods for handling the constraint. One method is penalty method, repair method, feasibility preserving and multi-objective methods. These are the four kind of methods that are available. When you use penalty method, it tries to modify the fitness. When you use repair method, it will try to fix the infeasible solution. When you use feasibility preserving method, it tries to design some operators. When you use multi-objective, you treat the constraint violation as objective. So when you want to obtain the penalty function method, say for example, my best choice is here, but I have a trade-off. So I need to achieve a balance between the trade-off as well as the. So I can add violation to find the cost. What are the ways I can add violation? So static penalties, dynamic penalties, adaptive penalties. So these are the three ways I can add penalty in order to nullify the constraint. So if it is a static penalty, it is a fixed coordinates. If it is dynamic, that is the change with the generation. If it is learned from the population. Everything is possible. But even though it looks very simple to implement, you should always be very careful because it is sensitive to parameter. What is the advantage and disadvantages? It is easy to implement, but on the other hand, it is very hard to set coefficient. So you should always over penalize the good infeasible solution. So that is the very risky factor involved in it. On the other hand, you can go for any other adaptive or dynamic schemes in order to mitigate, in order to avoid this constraint, because a penalty balance feasibility and the objective value. Objective value is optimal value, feasibility is whether that optimal value is feasible by satisfying the constraint or not. Another method, repair method. So the repair method, you can do these kind of things say for example, if you obtain a solution, the solution is infeasible. Rather than adding the penalty factor, you can do some repair. Say for example, you can do some repair in the crossover and mutation operation, or you can do some problem specific transformations, you can do some additional functions that may transform your problem to some specific scenario, or you may preserve by means of elitism like that and all, you may preserve the genetic material, or you can go for some kind of greedy approaches, right. So these are the way you can go for doing the repair methods. So constraints are most important one, and when you fail to handle the constraint, even though you obtain optimal solution, the optimal solution may go to infeasible solution. So you have to handle the constraint very well, and penalty method and repair methods are the two well known method for handling the constraint. Thank you.